It's the SMC Journal podcast where we talk about everything software engineering, whether you're in development, QA, test, operations, wherever you might be in the software development lifecycle, hardware, software, testing, tuning, observability, AI security, whatever it is, we're covering these topics for you. And this is something you're going to be really interested in today, I'm sure. I'm Scott Moore, your host. Thank you for joining me for today's episode. So everybody wants to know, how can we eliminate technical debt as early as possible when we're developing software? How can we make software more performant, more efficient, more secure, more accessible, even when we're writing code? Typically, developers are thinking about functionality first and foremost and shipping features as fast as they can. But what happens when they find out there are performance issues later on in the cycle? They have to go back and fix it. That is technical debt, and you don't want that. It's much more cost efficient to fix a performance issue, for example, in the early development stages. What if I told you that there was a new tool out there, if you're writing Python code, that will, as you're writing your code, make suggestions about how you could make it more efficient on the spot, tell you why, and give you an opportunity to make your code the fastest it can be as it's happening, as you're creating the functionality? Wouldn't that be cool? That's what we're going to talk about today. Before we do that, if you like this video and you like my channel, it'd be great if you subscribe to it, put a like on this video, ring the bell so you'll be notified when I create more videos. That helps me produce much better videos for you and helps people find this channel. So I really appreciate those of you who have done that. Today's sponsor of the show is Codeflash.ai, and we will actually be talking to the founder of that company. You can reach them at Codeflash.ai, and they create a way for you to optimize your Python code, any Python code, as you're writing it. And in some cases, you can write code that is tens or hundreds of times faster. So, what is this all about? It's the ultimate shift left. We're going to be talking to the founder today. Let's get right into the interview and find out more. Hey, Saurabh, welcome to the SMC Journal podcast. Great to have you on today.
Good to be here.
I want to talk about you and what you're doing with this Codeflash product that you've come out with. Why don't you introduce yourself to our audience? Who are you, and how did you get involved with performance stuff and code?
Yeah, so my name is Saurabh. I'm the founder of Codeflash. So Codeflash is an automatic code performance optimization tool. So it's an AI tool that looks at any code that you've written and figures out the fastest way to write the same thing. So the way I got into performance was like I did my undergrad in India at an IIT. So I did that electronics and computer architecture. So I was really deep into hardware. And actually my first job was at NVIDIA, where I was building performance tools for NVIDIA. So that they could make faster GPUs themselves. And from there, I actually pivoted to the field of machine learning and AI. Came to the United States at CMU, so did machine learning research, and actually worked and built some ML products and AI products at Silicon Valley startups and Meta. So all this while, I've been like really passionate about writing fast code, and that's like how I got into this idea itself in the first place.
So your background is you're a developer and you've worked at some cutting edge stuff. So let me tell you something. Just the fact that you said I'm a developer, but I'm thinking about fast code. I'm thinking about performance. God bless you, son, because we need you in our community of the performance engineering community. This is what I've been looking for. So talk a little bit about what the problem is that you're trying to solve and how CodeFlash does that.
Yeah, so with modern software, like consumers really demand fast software as well. What they want is that if they click a button, the results should show up right away. And I think there have been plenty of studies done. For example, I think Google did a study earlier where if page load time goes up by 0.5%, then their search volume drops 20%. That's a big number, right? So users are really sensitive around performance. So that's a very core requirement. But the problem is that the way software is being written today, that so the developer has to choose between either shipping features quick, they get a list of requirements, they have a long backlog, so they really are incentivized by the market to ship features quickly. And with that, they don't really get any time in a way to actually make sure that all the features and all the new code they are shipping is actually really high quality and performant. So in effect, they had to make a trade off between should they ship things quickly or should they make sure that all the existing things they have or all the features they have written, they are all very fast? And invariably, because of the market pressure, they end up choosing like shipping features quickly. And what ends up happening is that as these slow features hit this complex code base, things become really complex and things start like the slowness starts creeping up. And inevitably, we end up with this case today where we have a ton of slow code and it's super hard to fix it because fixing slow code means that a developer needs to find some time and actually go in and try to figure out like how do I speed this up, and which is a trade-off that people usually don't make. So this like how we end up with this world where we have a ton of slow code.
You totally get it. See, and this is what me and a lot of other performance engineers have been saying for years about, because what you've honed in on is the aspect of technical debt. Trying to fix performance issues, it becomes technical debt. And so everybody's been talking about shifting left for over a decade. But then you ask, well, what does that really mean? How do you actually shift left? Well, you have to get the performance issues out as early as possible, out of the, got to get the wrinkles out, the bottlenecks out, because the sooner that you do that, the more money that you save in the long run. And then you don't have all this technical debt. So to hear you say that is wonderful. Uh, Is there anything that we can do process wise so that we change the incentive for developers to think about performance from the get go? Is it as simple as when requirements and use cases are created, somebody is forced to put down a performance requirement for that code, or is it something else?
Yeah, so I think I started thinking about this problem of trade-off between shipping features quickly and shipping fast features. And I started thinking about how about we don't have to make the trade-off in the first place. Because if we do give this responsibility for the programmer to, you know what, you have to make sure that the code is fast, at the end of the day, you're making trade-off against something else, which is like writing more features in a way, right? So it's always going to be this equilibrium, and then equilibrium is going to shift towards like shipping features quickly. I don't think that's like the right approach to look at the problem. That is like force developers to go and like make their code fast. I mean, obviously we can do it, but it's going to hit a limit. So the way I think about it is this is where I think performance tooling can come into picture. And the way I see developers' responsibility changing is I think that developers in the future are going to be responsible for making sure that their features work and it's supposed to do what they do. And the tooling will get so good that all the features they have implemented, these tools will figure out the best way to make it most performant. So you basically get to ship things quickly as well as have those things be really fast.
I was talking to somebody who was part of the foundation of building the DevOps operating model, been a very big proponent and implemented it in very large companies. And he said this to me. He said, I appreciate you as a performance engineer, Scott, but when you start getting in my way of getting my features out and making me have to work more, you're ruining my life. So I'm thinking, how do I stay out of this person's way, but still get performance engineered into the life cycle instead of testing performance in at the end? How do I engineer it into it? And I think you're onto something here with making it very easy for a developer to use the tools they're already using, just bolt on something that happens, but it kind of stays out of their way, but it helps them get there faster. So that sounds like what you're trying to do at Codeflash. So can you talk about how you developed Codeflash, what it is, and how it helps developers?
So Codeflash is an AI tool that understands all the new code you have written and all the existing code you have written and basically asks the question internally, hey, could I have written this code in a better, faster manner? And it comes up with a few ideas. And this all happens with like advanced LLMs right now. And we come up with these ideas, we look at the original code, and then we run that code. To run that, we generate a bunch of test cases as well. And we run it, we figure out the behavior of the code, we figure out the performance of the code. And then we actually apply these new optimizations in, and then run it again, and then see is this new code, does it have the same behavior as before? But at the same time, is it faster or not? And we do this sort of constraint optimization on this problem. And then we figure out the fastest version of the code that has the same behavior, but just runs a lot faster. So with this, what's going to happen is the developer only writes the first version of the code, which works, and the developer tested that what is doing what it's supposed to do, and Codeflash runs in the background, looks at that code, figures out that what, this code, if you were to write it this other way, this thing would be 2x or 3x faster.
I could see where this would really help junior developers, people with a lot less experience. But then on the other hand, don't you need the experience of knowing if that change is something that really needs, but knowing the context to say, yeah, that looks like it's a great idea because it's faster, but it doesn't necessarily have the context of everything else. Like it, what level do you need to be at to take advantage of this?
I mean, we have had some really, really expert people get their code performance optimized with Codeflash. So, like Pydantic, for example, like we optimized a lot of their existing code, and they are some of the best people out there, right? So the problem with performance itself is human attention in a way. So doesn't matter if you're a junior programmer or a very top programmer, it still takes your attention to figure out that, hey, could I have written this in a better manner? And that's something that developers don't have that much, right? That's like the main problem. So once you have tools like Codeflash, which are essentially just software, you can scale that attention infinitely. So you can make sure that all the new code that's been written is performant, and all the existing code that's been written is also performant. So I don't see this really as a difference between like junior or senior programmers. And actually, for junior programmers, I do think that Codeflash is a great learning tool as well, because when Codeflash says that, hey, you know what, if you were to write this other way, this would be this much x faster, this is happening in the loop. So the programmer just learns that, what, this is, if they write code like this in the future, they would be able to write a lot faster code.
I can already hear you hear that echo out there in the internet. I can already hear there's people saying, "Hold on a second. If this is real, I got to see this." So my understanding is you actually have a demo you can show us. Is that right?
Exactly, yeah.
Okay.
Let's
All
let's
right.
go through it.
Let's watch this demo and we'll show everybody what you're talking about.
Here is how Codeflash works. So now imagine I'm writing a new feature for which I implement this function that finds common tags between a list of articles. So all the articles have these associated tags, and then I basically loop through all the articles and then find the common tags this way, and return a set of common tags. Now, I'm also a good engineer, so I write a test for it. And the test has these tags, and the common tags between them is Python and AI, which is what I assert. So now I want to ship this feature, so I just commit it and push it to GitHub. So now this is going to create a new pull request over here. I choose a write base repo and then create the pull request. So now, since Codeflash is installed into this repo, this will start running as a CI time GitHub action check. And if I look into this, so Codeflash first sets up the project by installing Python, installing your project dependencies, and starts executing. So Codeflash first discovers all the existing tests you may have in your repo, and then it found this function that it wanted to optimize in the Git diff, and discovered one existing test for it, and starts generating new tests and optimization candidates for it. So here are the tests that it generated using LLMs. And it starts running these tests over the original code. So the two test cases we wrote passed, and the 31 LM generated test cases passed. And the runtime was measured as 774 milliseconds. So now we try these optimization candidate, and the first one we try is this. So this runs in 8.3439 milliseconds. So this is 91.1x faster, and all the test cases passed as well. And the second one is this. This ran in 8.57 milliseconds, so it's 89x faster. The third one is 90x faster, and the fourth one is 33x faster. So the fastest version is actually this one, and Codeflash then generates an explanation and then goes and creates the suggestion on the original PR. And here's how it looks like. It says that you should replace these lines with this one, and also explains that the runtime went from 774 milliseconds to 8.39 milliseconds. and explains why this is faster. So it's using sets and using this intersection update function of the set, and then all the existing test paths and the generated test paths as well. So now I'm confident about this suggestion. So I go ahead and just like accept this change, and my code just got faster.
That was pretty awesome. But I did notice that it is Python code. So is this centralized around Python code only, right?
The implementation of Codeflash is very language dependent. So we're starting with Python and we're getting good results over there. But eventually, the plan is to build this for other languages as well.
And was that because you chose Python because that was what you had most experience in, or is it because there's a lot of development being done around Python and LLM development, stuff like that?
So Python has this um, a reputation of being slow. And unfortunately, when people write code in Python, they don't really understand what might be going on like a compute level. So they end up making a lot of mistakes. And Python is a very popular language. I think it's probably the second most popular language. And also, there's a lot of really heavy computing things that happen on Python. So it becomes this like language which needs a lot of performance optimization.
There's this chart out there that I've shared before online about how when I say expensive, expensive the code and the efficiency of the code is, and how much energy it takes to have code written and executing. And Python was way down on the list, and you've got like ANSI C way up here, like it's really really efficient. But then you have to balance out like the learning curve and the memory management and all these things where Python has much more of an edge where you can get code run faster. So you have to kind of balance that. But if you figured out a way to say, well, yeah, I mean, it's notoriously a little bit slow, but if we can fix that problem, now we get the learning curves over with, and we get the fast code. That's sort of a win-win for everybody.
And I think the way I see software development move towards the future, especially with AI tools, is developers really like to be really productive. So they have a feature, they have something they want to implement, and they want to be done with that quickly, as quickly as possible. And I think that's why Python is getting more and more popular because you can like ship a lot more things with Python than with like some slightly lower level languages. I think that's like the shift happening there. So I don't think that's going to reverse, and I think that's actually going to improve more and more because you will have things like Codeflash making sure that you do ship things quickly, which is like the main priority at most organizations. But at the same time, that code should be more efficient as well. So a lot of the ways like Codeflash make things efficient is by actually recommending that instead of doing it in maybe Python lists, for example, why don't you use NumPy for the same operations? And we automatically figure out that instead of doing these like maybe numerical operations you may be doing in Python, just use NumPy. And that's implemented in C. So that's how we get a lot of the benefits of Python as well as getting the performance benefits of like a lower level implementation.
I mean, that's great. And I liked how when you shared in the demo, where it gives you not just one, but maybe three or even four options. Some are faster than others. Some may be more meaningful than others. And it tells you, here's why. Here's why we want you to do this. You were talking about the training aspect of it. I mean, that's a great learning experience. Somebody like me, I dabble in it, but I'm not a developer full time. I'm more of just a software engineer. But that really helps explaining that in the demo. So that was very very cool. So let's talk about the future of this. Where do you think we're going to end up in the next few years as if we keep going this direction?
I think in the future, all new software will be by default fast, and performance won't be an afterthought that someone gets to later on when it becomes a problem. So I think we are going to have a lot more continuous optimization that even before the code hits production, and is merged into main, tools like Codeflash will automatically figure out like the best way to do that and implement that thing. So you get to ship things quickly, but with tools like Codeflash, you won't have this technical debt of performance like pile up over a period of time. It will be paid off even before it hits production.
To hear you say that performance can become an afterthought. Now, I hear that, and as a performance engineer, I'm also always going to be skeptical. I hope that that is our future. That is my desire. I would like to put myself out of business where I never have to even help anybody with performance issues. But to hear you say that gives me a little bit of hope. I hope that that is where we go from here. Now, the other aspect of that is okay. That's great, and we always want to get those optimizations in the code. But there are things when you were talking about how page response times or end user experience where the users are experiencing delays. Your code may be really fast. The database may be really fast. The network may have a giant pipe and plenty of bandwidth, but there still may be a slowness issue because of things that are outside of the area of the code. And that's where the performance engineer comes into play and says, okay, if you've taken care of the code, then let me take care of all these other things that are you've taken care of trees. Let me take care of the bigger forest and make sure everything is taken care of in performance. If we could get a world where that was working together, I think that would be the perfect world, in my opinion, from a performance standpoint. Where if people want to find out more about Codeflash and try this out for themselves, where should they go?
I mean, you can actually use Codeflash today on any Python project by going to codeflash.ai and then just like signing up to it and then just installing it as a pip package. It should be pretty straightforward setup process. No, I think this is like a really interesting time right now, where with LLMs and AI, completely new like entire domains of software engineering are being reimagined. And I think performance being this is this like constraint optimization problem where you don't have to change the behavior of the application, but then just like make it fast. I think this is particularly suited for automated systems to come in and figure out like the best optimization there. So I think this is like the direction we're going to go towards, where all the future code will be fast by default. And I think this is just the beginning of the things we're going to see here.
I agree, and I think what you just defined is what I would call dev perf ops, and now you're part of this community now, whether you like it or not.
Exactly.
So, thank you so much for being on the program today. You're welcome back anytime. And as this thing evolves and as it moves, come back and tell us about what you're doing with it. Give us some updates on it, and we'll have you on again.
Perfect. Yeah. I mean, I look forward to being back here again.
Thank you. So I know this product is sort of early in the market. It's in the early stages right now. There's going to be a lot of additions to it, a lot of enhancements to features and functionality. But I think this is off to a great start. And really, you can tell during the interview, I'm very interested in this because I'm finding developers now that are really getting it. They understand the fact that performance does not need to be an afterthought. You need to be thinking about it from the time that you're looking at a user story, and there should be performance requirements right there. And these motivations we were talking about, I don't want to force developers to do anything. I mean, it shouldn't be like a tyrant telling a developer you need to make sure it's perform. They should want to make it performant because they understand how it affects the business and how it affects them down the chain. Like once it gets to an end user, developers should understand that that end user wants a great experience, and if they do, it's going to cause the company to do better overall. And eventually, that comes back to the developers. They're the ones that are making this a great experience, a delightful experience, we sometimes say, for end users. It's all related, it's all mapped together. And to find developers who are getting that and creating tools to make that happen, like we were talking about in the interview, that would be such a wonderful world. So, what do you think about this? Are you going to try this? Are you writing Python code? I'd love to hear what you have to say. You can find me on most social media networks, but LinkedIn is primarily the one that I use the most. Or you can send me some feedback at heyscott@smcjournal.com. I'm definitely going to be taking a look at this myself, and because I dabble a little bit in Python, mostly because I want to see if I can write some stuff that will automate some things for my computer lab that I use in house on prem instead of in the cloud. I know, I'm a rebel. If you like what you're seeing on this video, it'd be great if you subscribe to the YouTube channel. That's as much as I'll say about it right now because I know I'm always bothering you to do that, but it really, really does help me. So, if you would like to see more content about from a developer perspective, how we can do more shift left performance optimization, totally open to doing it. I just need to know, who do you want me to talk to? Give me some suggestions. So, for today's episode, this is Scott Moore. Thanking you again for watching. We'll see you on the next one. Bye bye.